I've compiled 35 hard SAT math questions to help boost your score. These questions do not show up on any of the Blue Book practice exams, so there's not going to be any spoilers, and I made sure to include every single type of math question that you'll come across on the SAT. Let's get started. All right, first one here. It's asking us about the value of x plus 6, and it gives us a little equality here. And there's a couple of shortcuts for this. The first one would be to say, if they're asking me about x plus 6, I can just pretend that x plus 6 is my variable. So I could say, for example, x plus 6, we're just going to say that actually equals y. So instead of x plus 6 over 13 and x plus 6 over 3, we could have, y over 3 equals y over 13. And that's one way to think about it. But if you look at this, there's also just a pretty obvious answer, which is, what in the world could possibly be in the numerator and have two different denominators and still be the same number? No matter what number I put in there, it seems we're going to have different numbers, right? If we had 1, it'd be 1 over 3 versus 1 over 13, 2 over 3 versus 2 over 13. They're all very different numbers. The only number that's actually going to work would be 0. So we know that x plus 6 equals 0, which would be between -2 and 2. So it would be choice B. Alternatively, we could just plug this into Desmos, just in case that didn't, become apparent to you. So again, we could just do y over 3. Since we know that x plus 6 is the thing that we're solving for, we just say, well, let's just solve for that instead. And then it's at 0 because 0 is our answer. So a couple different ways to go about that one. But yeah, B is going to be our answer. All right, make sure to pause the video and try this on your own first. So anytime we are dealing with no solutions, two things are true. Thing number one, you have the same slope. So I like to get these looking more like each other. So I would expand the right side into AX plus AB. And if we have the same slope, well, our slope is 9. The coefficient for X is our slope. Here, the coefficient for X is A. So we know that A equals 9 because they have the same slope. So number one is definitely going to be true. The other thing about no solutions is that the y-intercept is not equal, because otherwise you would have infinite solutions. So we know that 5 cannot equal AB. So 5 is not allowed to be equal to AB. And since I know that A is 9, we know that 5 cannot be equal to 9B. And if we were to isolate B, we would divide by 9. 5 over 9 cannot be equal to B. So we know that 3 is true. Number 2, B equals 5. That doesn't have to be true. We could set B equal to 5 and everything would still be fine. So our answer is going to be 1 and 3. All right, pause the video, try this on your own first. So anytime that you're dealing with a table and you're being asked about something that can be seen visually on a graph, or something like the slope, we've got a new shortcut since 2025 with Desmos. So we're going to plug in a table, and you can type the word table. Ta-da! And the great thing is, if it's just a line, we don't even need all of these points. We literally need just 2 points. So I'm just going to put the first 2 points in here. -11, -10, 18, and 21. And then I'm going to hit this little guy right here. Here, let me expand so you can see better. I'm going to hit this little guy right here for linear regression. And boom, it gives us our line so we can visually see things that we're looking for. It also gives us the slope in case we're being asked about the slope. But in this case, it says, what is the x-intercept? X-intercept, -4, 0. That's our answer. Pause the video, try this one on your own first. But here we go. There's a really cool shortcut for these types of questions. In particular, I'm talking about when we're asked about an increase. If we're just being asked about an increase and we have a linear equation, which we do here, right? We don't have x squared or anything raised to the x. So this is a linear equation. The trick is we don't care about the y-intercept because remember, the y-intercept is basically our starting point. That's going to exist no matter what. So if we're just being asked about an increase, all we care about is plugging in x, multiplying that by our slope, which actually represents our constant rate of change, our constant increase, and that's our answer. So what I'm going to do is I'm going to ignore 32. I'm also going to ignore this number because it's going to get added to 32. And all I care about is 9 over 5x. And it says we want to increase by 2.1 kelvins. So I will pull up Desmos. I will say, hey, Desmos, what is 9 over 5 times 2.1? 3.78. And that's all I care about. So that's my answer. All right. Go ahead and try this one on your own first. But here we go. So x equals 2. Anytime we have x equals something, that means it is a vertical line. And I can show you this too. And if you didn't know this, you could just plug it into Desmos real quick. And you were like, oh, vertical line. And a vertical line, if we think about rise over run, it's going to be how much a line goes up and how much a line goes over. So this line goes up for infinity. So our numerator is like, what is the infinity symbol? It's like a little 8. Just looks like an 8. But anyway, the denominator, it doesn't go over at all. So the denominator is 0, which means this is undefined. But it's not asking us about a parallel line. It's asking us about a perpendicular line, which is the negative reciprocal, which would be, the infinity sign is supposed to be a sideways 8. That's why. Okay. Anyway, but the perpendicular to this would basically be if we had 0 over infinity. 0 over infinity. I know it's a very ugly infinity. And then, in that case, our slope would be 0 because we are allowed to have 0 in the numerator. And technically it'd be negative 0 over infinity, but negative 0 is still just 0. So our answer is A. All right, pause the video, try this one on your own first, but here we go. So you could plug this into Desmos, but you end up getting some numbers that are not whole numbers and it's not super friendly. I would say if you can see that you're dealing with fractions in your answer choices and they're not really clean fractions, like, I don't know, 1/2 or something like that, you're probably better off not using Desmos. And in this case, they're talking about an x-intercept at a0. So we can just plug 0 in for y, which makes this disappear. And then we get 7x equals negative 31. So then x equals negative 31 over 7. And then for the other one, it's basically the same thing, but the y-intercept. So we could plug in 0 for x, and then 2y is going to equal negative 31. So then y equals negative 31 over 2. And now we just need the value of b over a, which would be negative 31 over 2 divided by negative 31 over 7. So first of all, if we have two negatives being divided by each other, we can get rid of the negative sign, right? That'll become a positive. So I'm just going to turn them both positive. And then if you want to divide fractions, you just multiply by the reciprocal. So remember, b was going to be our numerator. That was 31 over 2 after I turn it positive. And then to divide by 31 over 7, we multiply by 7 over 31. And then since 31 shows up in the numerator and the denominator, we can cancel that out. And we are left with our fraction, 7 over 2, which is our answer. All right, try this one on your own first. But here we go. I think I mentioned earlier that if you have no solution, the first thing that's true is that you have the same slope. So that's right. A equals 2 because our slope is 2. Easy as that. Try this on your own first. But here we go. This is almost exactly the same as the last one. We have no solution, which means same slope, 1 over half x. That means c is 1/2. All right, pause the video, try this one on your own first. So for this one, I like to just use Desmos for inequalities most of the time. And we just will straight up put the inequality in there. So y is greater than 2x minus 1. 2x is greater than 5. And it's asking about all the y coordinates that satisfy the system of inequalities. So just to make sure we're on the same page as far as what a solution is, it's wherever you have a crossover of colors. So we got the purple, we got the black, and then we've got this place where they both touch. So these are all of our solutions. If it's asking about y values, then basically we want to know, like, what are all the y values that would be in here? And we can see this point right here where it starts is 2.5 and 4. So everything above 4 is going to be the y values that work. So it's going to be choice B. If you weren't too clear on the visual there, you could also start plugging in answers. So if we did like y is greater than 6, then we can see that there's this little portion that's not included. Like, hey, let me in. But then if we change it to y is greater than 4, it's like, oh yeah, that covers everything. So our answer, y is greater than 4. All right, pause the video, try this on your own first, but here we go. So this is a linear equation, and a couple different ways to deal with this. Let me give you the more formulaic way. So we know that y equals mx plus b is our basic linear equation. And in this case, we know that Ken earned $8 per hour for the first 10 hours of work this week. So that $80 is going to be there no matter what. That's our starting point. That's B. And we know that he was paid $10 per hour. That's our constant rate of change after that. Because it is asking about the number of hours he needs to work the rest of the week, but it's also including that first 10 hours of money. So our answer for X is going to be hours, but our money is still going to include the first $80 that he made. Now, the issue is Ken only saves 90% of his earnings. So all we would have to do is take this and multiply the whole thing by 0.9. And then, since we're trying to save 270, we could set that equal to 270. And here we could plug this into Desmos. And yeah, we could obviously solve this out, but I like to throw stuff into Desmos whenever possible because not all of us are great at doing math on paper or mental math. So if you have 270 equals 0.9, 10x plus 80, then we're going to get our answer, which is 22. And then another approach that you could take is more of a back solving approach where you plug in the answers to kind of see what works. So we would still need to know that we're going to have $80 no matter what. So then we would need an additional, because we have 270 that we're trying to save, minus the 80 that we already have, we're trying to get an additional 190, right? So we could take our answer choices and start plugging them in and just making sure to multiply by 0.9 so that we know there's only 90%. So if we started from the bottom, since we're trying to get the least number, we would start with the lowest number, right? So we would have 16 times $10 an hour times 0.9. And we would see that that's only 144. But then if we change that number to 22, then all of a sudden we got 198. Remember, we were just aiming for 190. So that's another approach that you could take if you didn't want to do the formulaic version. All right, pause the video, try this on your own first, but here we go. So this is asking about factors of a polynomial. And if you remember, factored form of a parabola is going to be y equals a times x minus p times x minus q, where p and q are x-intercepts. And this is factored form. So basically, when it asks about a factor of p, it's asking about what are the x-intercepts of p. And we can see those because x-intercepts are where y equals 0. So we've got one here, which is -1. And we've got one here, which is +2. Just remember, because our factored form is x minus p, x minus q, and this carries over for bigger polynomials too, not just for quadratics. It's always going to be the opposite of what's in parentheses. Our factors would be x plus 1 because we changed that negative to a positive, and x minus 2 because we changed that positive to a negative. And then that's going to be choice D, which is our answer. All right, go ahead and try this on your own first. But here we go. We have this exponential function, and it's saying we want the population of the city to decrease by a fixed percent each year. Which of the following must be true? So our basic exponential equation, the very most basic, I would say, that we can think of is going to be something like y equals a b to the x, where a is our initial value, b is going to be our percent increase or decrease, and then x is going to be the time. So in parentheses, we want to see our increase or our decrease. So if we have a decrease, r is going to have to be negative because we want 1 minus something to make this negative value in parentheses. So r cannot be greater than 0 or greater than 1. So both of those are going to be out, right? Because we want r to be negative. Now the issue is choice A and B, r is negative in both of them. So we have to kind of think about what would happen. If r was less than -1, what would happen to our population? Well, let's do a little experiment. Let's pretend that we have a population of 1,000. If we throw that into Desmos, we have 1,000, and then we would have 1 plus, what's a number less than -1? We'll just say -2. And then we raise that to the y, and let's just say, I don't know, we'll say what happens after 3 years? Well, it looks like we have a negative population. After 4 years, we have a positive population. After 5 years, we have a negative population. So you see how weird things can happen because we're going to be going back and forth between negative and positive. So that's super weird. But if we go between -1 and 0, so if this is negative like 0.5, now, no matter what happens, we still have a positive population, which is, makes a lot more sense because you can't have a negative population. So logically, choice A falls into some issues, whereas choice B, you're going to reduce the population, but you're never going to go below 0. So choice B is our answer. All right, next question here. Go ahead and pause the video and try it on your own first. But here we go. So I like to start with the main question anytime we have pretty much more than a single sentence. And it's asking for one possible value of A so that these guys equal each other, right? So straight up, it is saying that they equal each other, and keeping in mind here that f of a and g of a is really just f of x and g of x. So it's really just asking for a value of x. So it might look like a, quote unquote constants question, but really it's not really a constants question. So I'm just going to pull up Desmos because it says such that they are equal to each other. So I'm just going to set them equal to each other. So f of x is going to be that equation there, right? So we have -1/2 x minus 4 squared plus 10. Whoa. Oh my goodness. -1/2 x minus 4 squared plus 10. And we want to set that equal. There's actually two ways to do this, so I'll show you both. We could set that equal to -x plus 10. And that'll give us our two options, right? 2 and 8. Alternatively, we could set them on different lines. You might want to do this because sometimes visually the straight lines are not quite as clear. But if we did y equals, and I don't think it'll let me copy and paste here. Oh, it will. I don't think that actually works on Desmos on the exam, though, so don't count on it. And then y equals the left side, y equals the right side. Basically, we just put both equations in. And then again, we're just looking for points where they intersect. So we would have same thing, right? 2 and 8. And in this case, I think the other way is a little bit better because here we can see the y values. Luckily, they're the same, so we don't really run into an issue. But if we're just looking for the x values, then setting them equal to each other, in this case, is going to be a little bit more straightforward. So yeah, either 2 or 8. I'll go ahead and put in 8. So pause the video, try this on your own first. Then here we go. We got another single variable equation. That is to say there's only x, there's no y. And yeah, Desmos is the way. SQRT for square root, 2x plus 6 plus 4 equals x plus 3. And our answer should be 5. Boom. All right. Pause the video, try this on your own first. But here we go. So this is asking us the value of p. And there's a bunch of stuff on the left side that we could unpack to get it looking more like the right side. But if we can get away with a bit of a shortcut, I would like to. So what I'm noticing is on the left side, we have p being multiplied by x, right? And we have p being multiplied by x here. So it seems like p is only ever going to be attached to x. So rather than foiling out this whole thing, I'm only going to foil out the coefficients of x. So 3 times p would be 3px. And then keep in mind we're subtracting 16 times x would be 16px, and that's minus 16px. And I can't just pull that out. I have to pull out every coefficient of x. So there's going to be one more. When we multiply 16x times 4, it would be minus, what is that, 64? Minus 64x. And all of that is going to be equal to all the x's on in the other equation, because it says they're equivalent expressions, right? So that's going to be all equal to negative 155. Beautiful. So from here, the first thing I would do is get rid of my x's because we have x's attached to everything and we're trying to solve for p. So I'll just say goodbye x's. And now, if I want, I can actually just write this into Desmos. You know, for sure I could do the math and go that route, but I want to be as lazy as possible and make sure I don't make any sort of calculation errors that will cost me points. So all we have to do is make sure that we turn p into x because Desmos wants you to use x. So we'd have 3x minus 16x minus 64 equals negative 155. And that'll give us 7. So our answer is 7. As always, pause the video, try this on your own first. But here we go. We are trying to look at this expression, which can be rewritten in this way. This is kind of similar to the last one. It's equivalent expressions, and the first step is always to get things to look like each other. So we would want to expand the right side. But again, just like with the last one, I really only want to figure out what a is. So anything that gets attached to a is going to be helpful. Now in this case, a is going to get distributed to everything. So I can really pull apart whatever piece of the equation I want. So I'm just going to arbitrarily go with this, the stuff that's attached to nothing. And in this expression, the only time that's going to happen is when we get 13a. So 13a is going to equal 1.17. And just like before, we can pull up Desmos, turn that a into an x. 13x equals 1.17. And it'll give us our answer, which is 0.09. Alternatively, we could obviously see that all we have to do is divide by 13. So we would have 1.17 divided by 13. And that can be written as a fraction as well, right? Which is 9 out of 100, 0.009. Either way, our answer is going to be 0.09. Okay, pause the video, try it on your own first. So this one looks pretty straightforward, And in some ways it is, but what makes it hard? I think it's going to be the fact that we have square yards, but the conversion they give us is not square miles and square yards. It's simply miles and yards, which means 1 square mile is going to be 1 mile squared equal to 1,760 yards squared, which makes a huge difference. So from here, basically, we just need to figure out how many square miles this is by using this conversion rather than this conversion that's not in square miles, right? So ignore that and focus on this instead. And now we can use dimensional analysis to make sure that we're keeping things in the right place. So if we have 11,863,808 square miles, or square yards, I'll just call it y squared. We want to multiply that by 1 mile squared divided by 1,760 yards squared. And the reason that we know it's going to show up in the denominator is we need to get rid of yards and have only miles. And by having yards in the numerator and the denominator, they're going to cancel out, right? Sorry, those numbers won't cancel out, but the yards squared can cancel out that way so that we're left only with miles squared. So that's a little trick to make sure that you don't accidentally multiply when you should divide and vice versa. So we'll throw this into Desmos. And obviously this is just dividing, right? We're just dividing by this. It was 1760 squared. And I think it's mad at me because I'm using commas. So let me get rid of those. There we go. And 3.83 is our answer. Just like that, we got our answer. All right, pause the video, try it on your own first. So we've got, it looks like, more than a sentence. So I'm going to start with the last question, which is, if she uses 5 ounces of blue paint for the second batch, how much yellow paint should she use? I kind of glance at the answers and I see the word ratio. So I know I'm dealing with ratio and proportion, which means we're usually going to have some sort of a fraction equal to a fraction type scenario. She created a batch of green paint by mixing 2 ounces of blue, so 2B to 3 yellow. She's going to use a second batch using the same ratio, so they will be equal. She uses 5 ounces of blue. And then she's going to use some unknown amount of yellow. And just for the sake of not confusing myself, I'm going to get rid of these letters. But let's just remember that our numerators are blue and our denominators are yellow. And then looking at the answer choices, it says how much yellow paint should she use? So you might be thinking, oh, we're going to solve for X. But then when we look at the answer choices, we have these comparison answers, right? 3 ounces more, 1.5 times more, 1.5 times this. So we could definitely just throw this into Desmos and get X. In fact, let me show you that real quick. We could also cross multiply, but again, if you want to, you can always just 2 over 3 equals 5 over X. Then we know that X is going to equal 7.5. We can also just look at this and we can see that in order to get from 2 to 5, we had to multiply by 2.5. So then 3 times 2.5 would be 7.5. Anyway, so X is 7.5. But then as we start looking at our answers, we can get rid of this. 3 ounces more than the yellow paint from the first batch would have been 6, so that doesn't work. 1.5 times the yellow paint, no, because we know it's 2.5 times the yellow paint. And then we get 1.5 times the amount of blue paint. And that we actually could have stolen from the first batch because it already told us that it's the same ratio. So that jump of 1.5, because 2 times 1.5 would be 3, 5 times 1.5 would be 7.5. So yeah, our answer is going to be choice D there. And I just explained 3 different ways of finding that answer, but I do like you guys to have options, and I feel like they're all equally fast. All right, cool. That's going to be the end of part 1, but go ahead and click here if you're a member, where I'll cover the remainder of the question types.